Okay, so as in the last video we have understood the diagram of the mass spring system, which is motion under elastic restoring force, which we can also known as Hooke's law, right? So mass spring system. So I just try to make you understand by the help of 3 steps. Initially I kept the body on its mean position attached to the spring, right? Then I stretched this spring and took this body to its extreme position, to its highest limit, right? Then when we're gonna leave that body, now this body will gonna have a restoring force which will gonna take this body, or which will gonna restore the position of this body. But we know that it will not directly go to the mean position, it will cover some extra displacement, right? So it will be again on its extreme position. So we have understood by the help of these 3 steps. Then I said elastic restoring force would be directly proportional to the negative of its displacement. Since displacement is always taken away from the mean position, and restoring force is making body go towards the mean position. That's why the Fs is directly proportional to the minus x. When we remove proportionality sign, we got is equal to and constant k, where k is a constant called spring constant, or you can say force constant. And if you want to find k is equal to negative of force, negative of elastic restoring force upon displacement. Today we are going to derive the formula for acceleration of mass spring system. Driving the formula for acceleration of mass spring system. Mass spring system. Now we are going to derive the formula for what? We are going to derive the formula for finding the acceleration of the mass spring system. See, here now we are going to use the Newton's second law of motion. According to Newton's second law of motion, F is equal to ma, right? According to what? According to Newton's second law of motion. According to the Newton's second law of motion, F is equal to ma, right? Now see, comparing this equation and this equation, let's call this equation as equation number 1, and let's call this equation as equation number 2. So comparing equation number 1 and 2, equation 1 and 2, F cancel, so ma is equal to negative of kx, right? What you need to find? You need to find a. So a is equal to negative of k upon m into x. This is the formula for finding the acceleration of mass spring system. Formula for acceleration. Formula for finding the acceleration of mass spring system. A is equal to negative k upon m into x. This was all for today.